Alright, hello Calculus 1 students. Today we're going to be going over Handout 19, the indefinite integral, and the net change theorem. So let's go ahead and start. This will be correlating with section 5.4 in your book. And recall that the definition of an antiderivative is if we have a function like this, and if we take the derivative of this function, we'll get this right here. That's the definition of an antiderivative, and so if our antiderivative, the most general antiderivative, will always take the form of f of x plus a constant. Okay, and so we're going to be using the fundamental theorem of calculus part 1, to take advantage of that constant. So fundamental theorem of calculus part 1 says that this inside function here, when we take the integral of this will in fact be the most general antiderivative, which is simply x cubed plus a constant. Alright, if you take the derivative of x cubed, you get 3x squared as per the power law. So let's go through some antiderivatives that we have in this table. So if you have a constant multiplied by a function here, we can rewrite this as the constant multiplied by the integral like this. Note this is very analogous to our antiderivative rule that we came up with in the previous handout. And you should be able to see that this is true simply enough, because when you take the antiderivative of this, you just get the antiderivative times the constant, and so whether you multiply the constant before or after does not matter. Alright, so the next one, if you take the antiderivative of a constant k, well, your result will simply be constant times x plus c. So if you take the derivative of this, you simply get k back. Alright, so the integral of the power rules, we're just applying the antiderivative that we've already came up with earlier. And so we have x to the n plus 1, we go up by 1 power, and we have to divide by that same power we have there, and don't forget to add the constant. Okay, and anytime you're taking the integral like this, if it's an indefinite integral, that is, the integral has no bounds, there's no a and b, those two are gone. It's what's called an indefinite integral, and if you do not have this constant right there on any one of these, well, then your answer will in fact be wrong. So do not forget to include that constant. Okay, antiderivative of secant squared. Well, recall that if we take the derivative of the tangent of x, that will get us secant squared. Okay, I'm going to leave that bottom one for us a second later. If we have the integral of f of x plus or minus g of x, well, we can just evaluate those separately. Like so. Alright. The integral of e to the x, well, the antiderivative of e to the x is simply e to the x. Only this time include a constant. So if you take the derivative of this, you'll get this back. Alright, the antiderivative of cosine. So we know we got to have sine over here plus a constant. So if I take the derivative of sine, what do I get? I get cosine. Alright, so sine. Okay, so we know we got a cosine here. And if I take the derivative of cosine, I will get a negative sine x back. So I need to counter this by including a negative sign right there. And so now if I take the derivative of this whole thing right here, I will get a positive sine x back. Alright, so now for the bottom two, you may recognize this, hopefully you do, as the derivative of the inverse sine of x. And recall, if this was a -1, it would be a negative inverse cosine. Don't forget the constant. All right, this next one, and you should be able to do this with all the inverse functions, trigonometric functions we've gone over. We're just doing a preview of some. This one, as you may recall, is the inverse tangent of x plus c. Now, I will warn you, there is a Cal 2 teacher at this very university who will tell you that this is her favorite antiderivative. So do yourself a favor in case you land yourself in her class. She is an excellent professor, but if you do land in her class, I'm not going to name her by name. This is her favorite integral, so I would definitely take the time to make sure you know this one. All right, so let's do a couple examples. So this one, recall, this is the same thing as x to the -6th power dx. And now we simply apply the power rule for antiderivatives, right? We have that right up there. So -6 plus 1 is -5. And we're going to divide by that same number, a -5. Don't forget to add the constant. So if you take the derivative of this guy here, you will get this guy right back. Okay. Next one. Now we have a sum of 2. Now we just deal with them individually as per this law here. And so this becomes x cubed, right? And we don't need to put a number underneath since we have a 3 already hanging out there. So 3 divided by 3 is just 1. So we'll leave that one alone. And then plus someone's favorite antiderivative. So that's simply the inverse tan of x. Do not forget to add the constant. All right, so we're going to follow this up with the net change theorem. After examining this a little bit, it should be kind of just an obvious one. But if we're taking the antiderivative of something that's a derivative here, well, then we just take the antiderivative f of b minus f of a. Nice and simple. So we're going to find the position change for an example here. Find the position change from 0 to 10 seconds if the velocity is given by this function right here. All right. So this is a net change theorem. So we're going to set this up because note the integral of the velocity is simply going to be the position function. So we have the integral from 0 to 10 seconds, and we're going to stick our velocity function in there, which is 6t plus c. Right. There we are. All right. So, dt is what I meant to say. All right, so now we're going to evaluate the antiderivative. And so this is going to be t squared divided by 2. Right? If we take the derivative of this guy, you'll get this guy back. And we are going from t equals 0 to 10 seconds. First off, let's go ahead and simplify this down. So 6 over 2, that's 3 times t squared. Again, going from 0 to 10. So we plug that in. 3 10 squared minus 3 0 squared. Right? This is f of b minus f of a, just like we have over here. And so, of course, 10 squared is 100. And so this all becomes 300. And that was in, we'll assume it's in meters. It could be in feet because it doesn't specify. So yeah, in 10 seconds, this object traveled 300 meters. Okay? And that is that. That is the indefinite integral and the net change theorem.